Uh, Thanks for coming to my talk. Quick show of hands, who have seen any of the other talks I did today? Not a lot of people. Okay, good. So, thank you for coming. And today we're going to talk about creating your first scriptable brush and scriptable tile. So the scriptable brushes and tiles are two very powerful tools created by our 2D team based out of Singapore. And they can really help you to create beautiful levels and 2D games. So my name is Jay Santos. I'm Unity's lead evangelist for the SAPAC region. And here's what we're going to talk today. So after this session, you will be able to create scriptable brushes and scriptable tiles to take your 2D game to the next level. And better identify opportunities where you can benefit from the use of these two tools and compose levels much faster due to the reusability of scriptable tiles and brushes, meaning that the tiles and brushes that you create for a game can easily be reutilized on any other 2D game. So before I continue, just a little quick background of why I decided to create this presentation. The 2D team have also created, while they were developing the tools, they also created a demo called RoboDash, which is available, and I'm going to provide you guys the link later. And RoboDash have a lot of brushes and tiles that were created for that are beautiful and make very cool effects, but they're not very good learning tools, meaning that they're very complex, so it's hard to pick them apart and study them and understand how you can create your own tiles and brushes. So then I'm very excited about these two tools because, as I said, they're pretty cool. They really make it very easy for you to create your 2D games. And I wanted to create simpler examples to help developers get started, and for my own benefit as well, so I could better understand how they work. Now, before we move into Unity and start the demo, I just want to go over with you to some of the basic tile map terminology that we will use during this presentation. Right? So the tile map basics. So first of all, you have the component called grid. And I like to make a parallel between 2D and the 2D components and the UI components. So in broad terms, you can think of the grid as your canvas. It is the main basic component to create tile maps in your game. Now, within the grid, you can have tile maps. You can have more than one tile map. And these are the game objects where you paint the tiles onto, where you will effectively create the tiles. Right? And once again, making a parallel, they're like layers of Photoshop. The tile map renderer is a component which will actually effectively draw the tiles in your game. The tile palette is the window where you're going to have the tiles available to paint and also the brushes that you're going to paint. And finally, the tile, which is the asset which holds the basic information you can paint, like the sprite, the color value, and the color type. Right? Moving on, so the definition of scriptable tiles and scriptable brushes. So what is important to highlight here is that the difference between the tiles and the brushes is that the brush allows you to execute code when you effectively paint the brush, right? And it can also, I'm sorry, and so you can execute this code when you effectively, use the brush to paint. And the difference of the tile is that the tile have a behavior that is only applied within the editor, as you're going to see later. And as I mentioned, we have created this, what we call the 2D extras package, which we're going to make available to you. At the end of the session, I'm going to give you guys the link for the GitHub repo where you can download this 2D package. Finally, here's the list of methods that we're going to call in order to create the tiles and the brushes. These are what effectively will make, say, the magic happen, right? So first of all, in the tile-based class, we're going to call refresh tile and get tile data. So whenever you need to redraw a tile, refresh tile is called. And get tile data will return the rendering information of that specific tile. So this is what we're going to do. These two methods and this class is what we're going to use to create our scriptable tile. And for the scriptable brush, we're going to use the methods paint, erase, and onPaint scene GUI. So paint, as the name implies, will effectively paint one of the tiles of a tile map. Erase will do the opposite, will, of course, clear that specific tile. And onPaint scene GUI is editor GUI function that is used to update our grid brush GUI in our editor. We'll go over those in more detail once we talk about the code. Also, before I begin, just to mention what we'll be using today in terms of assets. So first of all, we have the 2D game kit, which was created by our Learn team. And it's a very cool set of 2D assets that contain sprites, animations, a lot of scripts, sound effects. It is a very nice 2D asset package that you can download for free in the asset store. And I've also used, we will be using what I'm going to be calling a gravity pad. And the gravity pad was not part of the 2D game kit, well, at least not yet. The gravity pad and the animations of the gravity pad were created by a very talented guy called Marcos Pena. And you have the link for his portfolio on the screen. So let's jump to Unity. And let me show you what I have right now. So what I have here is a basic, 2D level. My character runs and jumps, the camera follows along. But I have here this tall wall, right? And I cannot jump over this wall. My character doesn't have double jump, and I can't go over this wall. But what I do have is a couple of prefabs that I want to show you, which are what I call the gravity pads. So let me get here out of my scene so you can see better. So I have a gravity pad up and a gravity pad down. So if I run my game, I'm not going to run maximize so you guys can check it out. They have an animation. They are composed of a set of sprites. But they also have a box collider 2D, which you can see right here, which is actually set as a trigger. And they also have an audio source. And I want to use these guys, these gravity pads, to make a gravity inversion effect in my game. So my character is falling down, gravity is pulling my character down, but when I step on one of these gravity pads, my character is going to start to be pulled up. And if my character is being pulled up, I step on the gravity pad, I start being pulled down, right? And I could position, let me just delete these two guys here and get back to my scene. I could potentially, position these gravity pads manually on my game, right? I could try to manually include them in my game, But as you can see here, if I do this now, these vines are in front of my pad. So then I would have to control the depth of my pad to not conflict with this vine. And I could accidentally position one pad lower than the other, and that would look weird in my game. And I'd have to manually add them, and that is error prone, right? So what I want to do is I want to paint these prefabs on my game, on my tile map. Because when I do that, it is much easier to position these pads, and they also going to be perfectly aligned with the other sprites on my tile map. But the problem is that the default brush, it only paints sprites. And as I said, you have a slightly more complex game object here with an audio source and a collider and animation, so on and so forth. So what I want to do is I want to create a brush that paints prefabs, that will actually paint the gravity pads prefabs. We're going to check the code in a second, right? So what I have here right now is I have a file called GraphBrush. And when I click on Create on my Project tab, I have a GraphBrush option. So I'm going to create a GraphBrush. And when I create the GraphBrush is actually a scriptable object. I'm going to call it UnitedSoul Brush. So now I have here a scriptable object called UnitedSoul Brush. And this scriptable object have several variables. I have an up arrow and down arrow, up offset, down offset. I have all these configurations that I can set. And when I create this GraphBrush, if I go back to my Tile Palette tab and click on the pull down, I now have my UnitedSoul brush right here. And if I select it, I have all these variables here which I can set, right? So for the up arrow, I just simply drag my gravity pad up prefab. For the down arrow, I'm going to get my gravity pad down. I'm going to configure an offset here for my pads so they can correctly align with the rest of the sprites. And now I can just set there. And now with this brush selected, with the UnitedSoul brush selected, I can select my paint, my brush button, and I can click and paint a gravity pad. And now this gravity pad is perfectly aligned with the rest of the sprites in my brush, with the rest of the sprites in my tile map. I'm going to paint one on each side. And I'm also, when I press the space bar, I actually invert which gravity pad I'm painting. So when if I'm painting the gravity pad up and I press the space bar, I start painting the gravity pad down. So now, if I run my game, and I step on the gravity pad, I didn't have an animation to flip the character, so that's why it's just immediately flipping. But now, my gravity is inverted, so I've added this behavior to my character, right? And if I step here, I'm back to the original gravity, and I can get to the other side of the wall. Right? So I have this behavior now on my game, right? So let's have a look at how this is being done, right? How this brush is behaving, how it is effectively painting these gravity pads on my game. So I'm going to open my gravity brush, which I should have opened before the presentation. Now I need to wait for Visual Studio to open. There you go. Okay, so let me increase the font size for you. Okay, so we start with the class GraphBrush. So first of all, GraphBrush inherits grid brush base, which in turn inherits scriptable objects. GraphBrush, I have added to GraphBrush a couple of attributes. An attribute called create asset menu and an attribute called custom grid brush. So create asset menu is the attribute that is going to create the entry on my create menu for me to effectively create the scriptable object. And the custom grid brush attribute is the one that adds to the list of brushes on my tile palette window. This is the attribute that adds my brush to that. Now, I have here a handful of variables. So I have the two prefabs I want to paint, the up arrow and the down arrow. And I have offsets for X, Y, and Z, just in case we need it. And well, in our case, we are offsetting X and Y. If you want to offset Z as well, that's okay. And I finally have a Boolean that helps me define which one of the gravity pads I'm going to paint. If I'm going to paint the gravity pad going up or the gravity pad going down. Underneath it, I have the paint method, which we talked about during the PowerPoint. And this is a virtual method of the grid brush base class, which I am implementing here at the GraphBrush. So what I'm doing in Paint. So the first thing I'm doing is I'm getting the coordinate of the cell I've clicked. Now, an important distinction here is that this position, this coordinate, is the coordinate of the cell on the tile map. It's not the world coordinate. So this could be something like 0, 0, 0 if I clicked on the central cell of my tile map. If I click the cell right next to it on the right, that would be 1, 0, 0. The next one, 2, 0, 0. One up would be 2, 2, 1, 0, and so on and so forth. Now, to this position here, I will add the offset I mentioned, right? So I have here another coordinate that I call center tile, which is the center of the tile I've clicked plus the offset. So if I'm painting the up arrow, my center tile is going to be 0.5f, because my tile is, each one of my tiles is 1 by 1, plus the offset. Now, we'll get back to this method in a second. The next thing I do is I instantiate the correct gravity pad. So if paint up arrow is true, I instantiate the up arrow, otherwise I instantiate the down arrow. After I did that, I call setParent on this game object I've just instantiated, and I'm setting this game object as a child of the tile map I just clicked. So brush target is the tile map that is selected right here. So in our case, the brush target is the tile map graph pads. So what I'm doing here is I'm setting this instance of my gravity pad as a child of this tile map, and you guys are going to understand in a second why I'm doing it. Finally, I am setting the position of the game object I've just instantiated, and I'm doing it calling this method local to world on my grid. So local to world gets the grid coordinate of the cell we just clicked and translates it to world position. And to that world position, I am adding the offset. And that is it. This is all you need to do to paint the prefabs, right? However, right now, we are having a slight problem. if I go back to my scene, you can see that the gravity pads I painted, they're all set as children of the tile map, right? Like I mentioned, when I instantiate the object, I set its parent, and that's it. So they're all children of the graph pads tile map. However, look what happens when I paint a graph pad. Oh, I painted wrong. Let me erase that. And let's try it. There you go. So I painted a gravity pad on this tile here, right? So I already have a gravity pad on this tile. Pay attention here on the list of children of my graph pads tile map, and look what happens when I try to paint another gravity pad on the exact same position. I am adding a lot of gravity pads at the exact same coordinate. If I select these objects here, I can see that I have a lot of them being placed in the exact same position. So that is a problem, right? Because the moment my character steps on this trigger, the onTriggerEnter method is going to be activated on all these instances of my gravity pads. So I'm just going to have my character crazily changing gravities at this position here. And I don't want that, right? Another examples of why this is bad. Imagine that you want to paint a medikit that is going to give your character 10 points of health. What's going to happen if you paint 100 medikits at the same position? Your character is going to get 1,000 points of health. Or maybe you are painting a coin that's going to give your character 10 points. If you paint 100 coins one on top of the other, your player is going to get 1,000 points. So we need to prevent that. We need to avoid this to happen, right? I'll just delete all these guys here. There you go, first. Okay. So how can we do that? So I have a method here called getObjectInCell. So this is a method I've created. These have nothing to do with the grid brush base class. And what getObjectInCell is doing is, so first of all, I send to getObjectInCell as the parent variable the tile map on which I'm painting, so the graph pads tile map. And then I get the number of children that my tile map have. After I did that, I get the world position of the cell I've clicked. Once again, when I click the cell, I have the coordinate of it in the tile map. I'm simply converting that to a world position. And then, I just set a variable of the bounds class that would create me a bound, a square, of the same size of my cells. And after I have this bound, I'm going to go over all the children of my tile map, and I'm going to check if the position of these children is within the bounds, meaning if this children is in that cell of my tile map, and if it is within that cell, if its tag is either up arrow or down arrow. If I go to my prefabs, you can see that they are tagged. So this one is tagged as down arrow, this one is tagged as up arrow. So, if there's an object on that grid cell position and it's tagged as either up arrow or down arrow, that means that at that cell, I already have something painted. So I don't want to paint anything else here. If I have nothing painted there, I just return null. So if I go back to my paint method, I check if my getObjectInCell method returns anything different than null, I return, and I won't instantiate my game object, and I won't position it in my world. And that's it. So if I go back to my game, and I try to do the same thing. So I'm going to paint. Let's zoom in so you guys can see. So once again, pay attention here on the number of children of graph pads. So if I paint a graph pad here, and I try painting again, now I cannot do it. Because now I know there's already an object there, and I cannot paint it anymore. Of course, if I try to paint on the cell next to it, it's going to allow me. One last thing that I want to show you is that, as I mentioned, I press the space bar to alternate between the gravity pad up and gravity pad down. But I need to tell my user somehow that they need to do that, right? That this is the way that you operate the brush. So the way I'm doing it is, if I scroll down on my grid brush file, I actually have another class here called Graph Brush Editor, which inherits from Grid Brush Editor base. And over here, the first thing I have is the method called onPaintSceneGUI, because getting keyboard events on the editor is slightly different than the way you do it in the game itself, right? So, so on this onPaintSceneGUI, I will check if I press the space bar. And how I check that? I get an event that happened, and if the type of that event is key down, which is equivalent to the input get key down, the input get key down method, and if the key code of that event was the space bar, I simply go to my gravity brush instance and invert the value of my paint up arrow boolean. And that's it. And finally, I have a method onPaintInspectorGUI. So this is what I can use to add any additional information to my tile palette window. And what I'm doing here is simply calling the GUI layout method, and that's just adding some text to my tile palette window describing what you need to do to use this brush. So if I go back to the editor, I have here my brush, I have a little bit of text here describing how to use the brush. One important detail here is that if you are using the onPaintInspectorGUI method, and as you can see, this is an override, make sure to call the base onPaintInspectorGUI method, otherwise you're not going to expose to your user any publicly made variable for them. So for instance, if I comment my onPaintInspectorGUI, look what happens on my editor. There you go. All my variables disappear. So I now have only the text that I was painting. I can no longer set those variables. So make sure, if you're going to do that, make sure to call the onPaintInspectorGUI method as well. Let's wait for it to come back. And there you go. Okay, so this, as you see, it's very simple, very straightforward to create your own scriptable brushes. Now let's talk about tiles. So over here on my scene, I have these vine tiles, which I'm using as, as flair, as juiciness to my game, right? And I can have several types of vines. I can have the vines at the corners. I can have straight vines horizontal, straight vines vertical. I have a whole bunch of different, I have T vines, so on and so forth. And I don't want to manually and individually analyze each position of my vines to know which one of the sprites I should use here. Should I use a straight vine? Should I use a corner? Should I use a vertical vine? I don't want to do that. I want to automatically analyze my surroundings and decide which is the correct vine to use. So for that, I have this vine here, which, sorry, let's delete that. Let's select the default brush. And over here, selecting this scriptable tile I already created, I can automatically decide which sprite I should use on each situation. Now, to get started with this, once again, I have here a script called Vine Tiles. I go to my Create menu, and here in the Create menu, I have a Vine Tiles option. I click on that. Let's call it Vine Tiles. And now, I have a new scriptable object called Vine Tiles, which have several variables, including an array of sprites called Vine Sprite. And on this array of sprites, I'm populating it with this sprite map I have here. Now, as you can see, I have every single possible variation of sprites here on my sprite map. So I have one sprite for each one of the corners over here. I have one sprite for each one of the T's. And I mean, this is a bit of overkill. I mean, I could have only one instance of the corner tile, and I could programmatically rotate it to have all 4 possible variations. I just decided to create all 11 possibilities on my sprite map just to make my code simpler. So I don't have to worry about rotating the sprite in code. So I'm exchanging a bigger sprite map for a shorter code. But that decision is up to you, right? So let's see now what I do on the Vine Tiles script. So, first thing is, my Vine Tiles class inherits the tile class, which inherits from scriptable objects. So over here, I have an array of sprites called Vine Sprites, which I populated with all the 11 sprites that I have. So I have here my Vine Sprites populated. And then I have the refresh tile method, which once again, it is a virtual method from tile, which I'm overriding here. And this is the method that is called whenever you place a new tile on your tile map. So what I'm doing is, I am checking all the surrounding sprites. So I placed a vine here. I'm going to check the surrounding sprites and check if they also have vines. So for each one of them, I call the check vine method, which simply, let's go down here, which simply return the tile that is painted on that position. So if the tile that is painted on that position is a vine tile, I return true. Otherwise, I return false. I go up there again, and if I do have, so let's say I just painted this tile here, I'm going to check the top tile. If that tile also has a vine, I'm going to call refresh tile for the upper tile. So I will recursively check all the tiles surrounding me to update all of them. And how do I do that? I do it on the get tile data method. So on the getTileData method, I'm going to check the surrounding tiles, and I'm going to create a mask. So if the top tile have a vine, I'm going to add 1 to the mask. If the right one have a vine, I'm going to add 2. If the bottom one have 9, I'm going to add 4. If the left one have 1, I'm going to add 8. So then I have 1 value for each one of the possibilities of each one of the possibilities of the scenario. So once I've calculated my mask, I call this method getIndex, which will simply return an index on my sprite array based on the mask. So depending on the value of the mask, I return a different index on the array. And once I have that index, I simply get my tile and set the sprite of that tile as the sprite that I have on the array. And that's it. That's all I need to do on my scriptable tile to add this behavior. I also have here the method that is added to my create menu, and that will effectively create the scriptable object. So this is also here in this class. So this is it. With this very simple method, I've created this behavior here. And as you can see, it correctly checks. So if I have this tile here, by default, it uses the first tile in the sprite sheet, which is the horizontal tile, the horizontal vine. If I paint it underneath, it automatically updates here. If I paint this one, I've updated only the one here in the corner, but if I paint it here, I'll have to update those two. Right? So I'm searching all my surroundings, checking for what tiles I need to update. So that is it. Let me get back here real quick to my closing slide. So on this URL, so tinyurl.com/2dextras, you will find the Robodash project repository where you can download all the other tiles that were created by the 2D team. There are some very interesting tiles like the rule tile, which you can create a whole set of rules to define which sprites to use. So you analyze all the surrounding tiles, all the surrounding cells, and depending on the value of each one, you define what sprite you want to use. So it's a way more elaborate scriptable tile, but that gives you a very powerful behavior. There's also a very interesting brush called the line brush that is used to create like this laser effect. So if a player goes through the laser, he dies. So you paint this cell here, and you paint this other cell here, and the laser is going to be painted like a line throughout these 2 points. So these are like a couple of examples of the brushes and tiles that you have on this repository. So thank you for your attention. This is my email, j@unity3d.com. Feel free to reach me if you have any questions about Unity in general. But of course, you guys have the Korea team, which is extremely competent and are very glad to help you as well. And I'm also at Connect on connect.unity.com/u/j. And I try to always post interesting tips on Connect as well. Okay? Thank you so much. Thank you.